what you find in the open ocean are so-called oxygen minimum zones, and they're typically located at a depth of around 1 kilometer. Not everywhere in the oceans, but I show you a distribution of these, which regions actually have more pronounced oxygen minimum zones. But this is a typical shape of these dissolved oxygen profiles. So what's shown here in the central graph is how the vertical profile of dissolved oxygen looks like. So you measure dissolved oxygen levels. You start at the sea surface and you repeat your measurements until you reach the seafloor, and which is on average 4 kilometers. Okay? And if you do that, what you find is, and this is a typical feature of the central Atlantic Ocean, you find an oxygen minimum zone. So why do you find a dissolved oxygen minimum zone in the Okay, so in order to understand that, the easiest way to approach this explanation is think about where does the oxygen come from, okay, and what is the reason that you actually lose oxygen in the ocean interior. So where does the oxygen come from? It comes from photosynthesis in the surface oceans. It comes from air-sea exchange. And that's talking about the surface. And this already explains why you have a high value near the surface. Okay? But at depth, where it comes from is something we call ventilation. This is supply of dissolved oxygen as part of the deep circulation of the ocean, which is in contact with the atmosphere in some regions, like Antarctic shelf seas or the Greenland Sea. Okay. In addition, there is not much reduction of oxygen in the deep sea. There is no bacterial activity, or very little bacteria. Okay, but at a depth of 1,000 meters, you have the zones where you have an excess of bacterial decomposition of organic matter, and this creates this minimum, also a lack of ventilation by oceanic current. Okay, so this is the zone. In the deep sea, you have a high levels of dissolved oxygen concentrations. Okay. Where does that come from? The oxygen, and I said that before, it's actually from the sinking particles of organic matter, so-called detritus, and the bacteria that reconverted into dissolved nutrient concentration. So already, let's have a look at what is the depth of this level of critically low concentrations of dissolved oxygen. So let's have a look at that. At what depth do you find this level in the ocean? And this is shown here on the next slide. Okay. It shows you the depth of the 60 micromoles per liter isoplath in meters. Where do you find the depth of where you have critically low dissolved oxygen concentrations? Have a look at that map with the lethal concentration. And so, okay, so near the surface, there's enough oxygen in all regions of the oceans. But you can see here in the Pacific Ocean, once you're in 800 meters, critically low levels of oxygen. Okay, or even 100 meters, 50 meters up here in the eastern tropical regions. And the northern Indian Ocean, very low at 200 meters. Okay, or even less in some parts. Okay, so this is what we call oxygen minimum zone, and it's a natural feature in the ocean, these oxygen minimum zones.